Lesson 13.4 is finding angles level 1 and 2. It says, in the diagram below, segment AB is congruent to BC. Remember, congruent means that they're exactly the same shape and size. It's just a mirror image of itself, or a copy and paste kind of situation. So I'm going to put that AB is congruent to BC with these little tick marks. And the measure of angle BCD is 115 degrees. They've already got it. They want us to find the measure of angle B. And so we just have to figure out some way to get that solved for. And my first thoughts are seeing these two congruent sides makes these two congruent angles. These are the base angles of an isosceles triangle. So angles across from congruent sides will also be congruent. And so right here I've got a linear pair. I could take 180 minus 115. And that tells me that this angle right here is 65. That means this angle right here is also 65. So to find this, I would do 180 minus 65, which makes angle B 50 degrees. Because remember, there are 180 degrees in each triangle. All right, number 2, it tells us that AB, which is right here, is parallel, is that symbol, to CD. And we draw little arrows on lines to tell you they're parallel. That means we can have those angle relationships that can be, alternate interior, alternate exterior, consecutive interior, corresponding, all that kind of stuff. And I see that this cut off. This is probably finding, it's got to be E. Find the measure of angle E. All right, so what do we know? We also see an angle here. So what I would think is, since this angle is 66, I could also say that here at angle FGB is also 66 because they are in the same place here, because this is my transversal, so they're corresponding angles. Then I've got a linear pair here, which would be taking 180 minus 66. That tells me that's 114 degrees. And then I'm working in this triangle so I can find out E. It'd be 180 minus 114 minus 23. That would be 43 degrees. You also could have seen that this angle here and this angle, they are same side or consecutive exterior, and they are supplementary. They add to make 180, so you could have jumped straight to that angle right there. All right, number 3 says that AB, so this whole line, is parallel to CD, and AD and BC are parallel. GD, so here to here, bisects angle ADC. An angle bisector means it cuts these two angles, or this angle, into two equal angles. Also tells me that GC bisects angle DCB, so these angles will be congruent. And measure of angle B, they've already got labeled, is 110 degrees. Find the measure of GFA. GFA. Looks like an obtuse angle to me. Okay, so what I noticed is this is not even in a triangle. This is in a quadrilateral. It has 4 sides. So let's see here. We've got if I could find this. I'm looking at these lines being parallel, so I'm going to highlight them. And then I've got this as my transversal. So this angle, that's 110 degrees. And this angle here, these are same side or consecutive interior, and they should make a 180. So if I did 180 minus 110, that would put this whole thing as 70. But I also know that these two should be equal. So if I split 70 in half, this would mean each angle is 35 degrees. And so then what I could do is see a different relationship as this line being my transversal. And so I've got this angle of 35 formed by my parallel, my transversal, and this angle down here at EFG formed by my parallel and my transversal. So see it right here and right here. It always kind of makes this Z shape. These two would be alternate interior, so that makes that 35 degrees. Then I would have a linear pair here where I could take 180 minus 35, which is 145. So that one was kind of tricky to get started because you're trying to think of consecutive or same side angles that are supplementary. And the last one, number 4, in the diagram below, line AE is perpendicular to AF. So AE and AF, that's why they make a right angle there. CF is perpendicular to AF, so there's another 90. And then segment AE is congruent to AB. And they give us the measure of angle EAB, which is here is 24, and the measure of BCD is 65. Find the measure of angle CDF. CDF. So we want this one. All right, well, I see a right angle here. So if I could figure out that, I could figure out that. Or if I could figure out that, I could figure out that. Let's see. I've got an isosceles triangle again, where these two will be my congruent base angles. So if I were to take 180 for my triangle minus the 24 angle here, 156 divided by 2 means each of these are 78 degrees. Then I could find this other angle here at B, because it's a linear pair. So I do 180 minus 78 and get 102 degrees. I also could find this angle here, since this is a 90. If I did 90 minus 24, puts me at 66 degrees. And I know this one. So right here, I have a quadrilateral that has 4 angles. I'm hoping you remember how to find the total degrees in any sided shape. Remember, it's always the number of sides minus 2, and it's that many triangles times 180. Well, if I've got 4 sides, 4 minus 2 would be 2. 2 triangles, which literally I could cut this into 2 triangles, would make 360 degrees. So there's 360 degrees in every quadrilateral. That means I could do 360 minus the 65, the 102, and the 66, and get this to be 127. Then I've got another linear pair where I could take 180 minus 127. And then that should be 53 degrees. So this is kind of hard to teach because there's just different cases all the way around. It's just you not being afraid to make a mistake, but kind of solving the puzzle in some way that you've learned in the past.